The topic of this tutorial is Choropleth maps for quantitative attributes. In the tips and notes section of about symbolization options, we have discussed the two major ways of classifying attribute data, namely by category and by quantity. By the way, the links to the videos are provided in the description below. And also in tutorial 2-1, we have seen how to classify by category. We classified the qualitative attributes of the land use types in valley mountains, or in terms of agricultural land, forest land, urban, and etc. We have classified it. Likewise, it is also possible to portray quantitative attributes this time using Choropleth maps. So in the next chapters, we will see some of the practices of doing or producing Choropleth maps for quantitative attributes. For example, the distribution of schools, or it could be clinics, or educational facilities across the city. This can be shown also with Choropleth maps. To do that, we must break the numeric attributes or the attribute data into relatively few classes. Each class will have a minimum and a maximum attribute values. So to symbolize map features, we need to set the maximum value of the classes, also called breakpoints. So to show how we can work with it, please open tutorial 2-4 project, and in the contents pane, click add the subcities as shown in this map. This is the map of the subcities of Addis. And if we open and study the attribute table, it has some data regarding some facts about the number of schools, hospitals, clinics, or educational facilities like universities or colleges, and also the total area. And these are disaggregated by subcities. So for example, if you want to study or to show the distribution of universities or colleges across the subcities, we can produce Choropleth maps. What we can do is first open the symbology pane for this layer, and as we have seen in the previous tips and notes, the videos, there are many ways of classifying the attribute data, as you can see here in the program, either by category or quantity. So pick this time graduated color. The default is the field in the attribute data, the first field in the attribute data, which is area. But first things, the map now shows the size of the areas across the regions, across the city. This is not what we want to show. So let's pick this column, university, college, or TVET. So the defaults, when we pick it, the default options are provided, as you can see here. 5 classes are suggested as a default. This is also shown in the map and in the contents pane. So the number of universities are shown with graduated colors. The more saturated the color is, it shows that there are more universities. The lighter the color is, the less number of universities there are. as shown here is where most universities are concentrated because it has a saturated color. On the other hand, Kolfe and Addis Katama is where there are least number of universities. For normalization, here leave it as none. We'll see it in the other section how we can use it. For method, the default method is actually natural breaks or junks method. But for a start, let's make it quantile for now. By the way, links to the videos on the discussion about the different symbology options is provided in the description below as well. So for classes 5, the default class is 5 or 5 type of graduated colors here. You can change it if you need to. But on the average, 3 to 7 classes are recommended. If we increase the number of classes, our mind will be overwhelmed. So it is advisable that we keep it as small as possible, 3 to 7. You can also change the colors here in the color scheme section. Now here is the color scheme section that we have picked. You can also change it according to your need. Here you see these are called breakpoints. Breakpoints are the values that separate the classes. Numbers found to the right of the interval, as you can see here. The first class is for those subcities with the number of universities from 0 to 9. So each class has a minimum and a maximum attribute value. The minimum value is included in the class, in the current class, but the maximum, or in this case, in the first case, it is 9, or it's also called the breakpoint. It goes into the next class to the right. For the other classes, the breakpoints are at the right side of the interval, as you can see there. So classification is about determining these breakpoints. Now let's click the histogram view to view some more details. In the histogram, or in the frequency distribution of the attribute data, we can see that these are the breakpoints as classified by the quantile method here, or the numbers that separate the classes. These are the breakpoints. 0 to 9, the first class. 9 is the breakpoint. 9 to 17, 17 is the breakpoint. 17 to 19, 19 the breakpoint. 19 to 25, 25 the breakpoint, and 25 to 51. You can also even modify these numbers manually by dragging them. So when you drag them, thereby you are also changing the map as well. But as you drag, the classification method will also change to manual interval. To see this, if you go back to the classes tab here, you see it has automatically changed it to interval. And the links to the videos on the discussion of the different classification method is also provided in the description below. I advise you to watch it. But for now, let's change it back to quantile for our purposes. Now close the symbology pane. Now next, Choropleth maps, are good to visualize quantitative attribute data. But just by looking at the colors, these graduated colors, one cannot easily appreciate the difference between each classes. What I mean is, for example, if we see this map, about the distribution of universities across the subcities, Yeka and Arada are under the same category. As you can see from the color, they have the same color. They are under the same class. Yet there is a difference among them still. But you can easily convert a 2D choropleth map into a 3D scene so that we can better visualize the data. We will learn later in the sections about 3D data and 3D scenes in the later sections. But for now, just to appreciate what we can do with it, we can do with 3D. In 3D, a map reader can appreciate an extreme values relative to other values, which are not apparent just by looking at the color shading using the color maps only. So to do that, let's go to the Views tab in the Views group, click Convert and choose Local Scene. So wait for it to convert to 3D scene. Now we will see how it differs with the global scene. Now there we are. A 3D map has been automatically opened. I mean, there are categories for 3D and 2D layers. This is a 2D map, choropleth map, and this one is a 3D map, also called local scene. But they look similar now. So what we contents pane, 3D scene, click universities layer or colleges. Now when we do, a feature contextual tab appears called feature layer here. Click the appearance tab, and in the extrusion group, click type and choose this one, base height. By clicking the base height, it first sets it to 0. Next, we will see how to set the extrusion height according to the attribute value of universities or colleges in the attribute data. To do that, in the extrusion group, for extrusion expression here, choose university, college, or TVT. The difference is still not visible now, and choose this one to make it visible. Now the difference is visible, as you can see from the map. In the 2D map, as we have seen, Akaki and Bole are in the same category, and also Nafasilk and Kirkos are also in the same category. But you see, Arada and Yeka are also in another same category. But we cannot appreciate the difference between them in the 2D scene. In the 3D map, the difference is clearly visible here. Even though they seem to be in the same category, they still have large difference within them. Arada and Yeka. So a 3D choropleth map is a powerful option.